Hello student, welcome to yet another explanation video from IIT Academy. At IIT Academy, math transforms into an exhilarating journey. Join us and ignite your mathematical passion today. So in this question, we have been given a rectangular cardboard piece with L is equal to 48 and W is equal to 30. It also says that the volume of the final box comes out to be Vx is equal to 48 minus 2x, 30 minus 2x, and x. And how is it done? You see, they are cutting out pieces here, 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 and here, right? And the four corners. So this is x, this is also x, this is x, this is also x. Similarly, all of them are equal to x. Now the first question is asking us, write down the maximum possible value of k. And what is this k exactly equal to? The maximum value x can take. Now we have two sides, right? The length and the width. We find that the width is smaller than the length. And if we go on increasing the value of x, what happens? The width gets exhausted much faster than the length. So to find the maximum value of x, we can equate this as 2x is equal to 30 or x is equal to 15. This is the maximum possible value of x, which is equal to k, which is equal to 15. Now in the second part of the question, they are asking us to find the value of x that maximizes the volume of the box. An equation for the volume of box has been given. Let's simplify that. Vx is equal to 48 minus 2x, 30 minus 2x times x. If we multiply the first two brackets, the expansion would be in the form of 1440 minus 60x minus 96x plus 4x square times x. If we rearrange this, then it comes out to be 4x square minus 156x plus 1440 times x. Now again, if we multiply these two brackets again, this comes out to be 4x cube minus 156x square plus 1440x. Now we know that to find the value of x that maximizes or minimizes Vx, we should put ddx of Vx equal to 0. So the first derivative of this expression, when equated to 0, will give us the value of x that either maximizes or minimizes the volume. Let's do that. So ddx of 4x cube will be 12x square. And which formula are we using over here? ddx of x to the power n is equal to n times x to the power n minus 1. So 4x cube will have 3 in front of it, and then x cube changes to x square, and 4 times 3 is 12, so that's 12x square minus 312x plus 1440 is equal to 0. Now if we divide everything by 12, I get x square minus 26x plus 120 is equal to 0. So this is the final derivative equation that we will get after equating this to 0. Now the only part left out in this question is to solve the quadratic equation and find the value of x. Let's say x square minus 26x can be written as 20x minus 6x plus 120 is equal to 0. If we take x common from the first two terms, it makes it to be in the form of x minus 20 minus 6 common from these two terms, x minus 20 is equal to 0. And then we will have x minus 20, x minus 6 is equal to 0. Now, we can say either x minus 20 is equal to 0, which gives us x is equal to 20, or we can say x minus 6 is equal to 0, which gives us x is equal to 6. We will try to plug in the values of x in the original equation itself to find which one gives me the maximum volume. So if we plug in x is equal to 20, I see that this middle term over here becomes 30 minus 2 times 20, which is equal to minus 10. So this gives us a negative value. However, if we plug in 6 over here, the volume becomes 48 minus 2 times 6, that's 12. 30 minus 2 times 6, that's 18, and then 6. So we see that this value over here is the positive value, and we will take x is equal to 6, which maximizes the volume Vx. Final question that this question is asking is to calculate the maximum possible volume of the box when the box has 2 centimeter cutout from each side. So if the patch of 2 centimeter is cut from all the edges, the new length becomes 48 minus 2 times 2, that's 44. The width becomes 30 minus 2 times 2, that's 26. Now, how is the volume affected by this? The equation of the volume? Vx becomes 44 minus 2x times 26 minus 2x times x. Now they are asking us to find the value of x for which the volume is maximum using the new equation that we found. Let's very quickly do the same thing that we did in the second part of the question and equate d dx of Vx equal to 0. Before that, we need to simplify this equation or expression rather. This is equal to 44 times 26. You can use your calculator to find what's 44 times 26 and you will find this to be equal to 1144 minus 52x minus 88x minus 4x square times x. If we try to solve this, let's first rearrange this. This should be plus rather. This is 4x square minus 140x plus 1144 times x, which is equal to 4x cube minus 140x square plus 1144x. Now, if we try to differentiate this and equate it to 0, then d dx of vx should be equal to 0. Using the same formula, d dx of x to the power n is equal to n times x to the power n minus 1, we can say 12x square minus 280x plus 1144 is equal to 0. Now we have got this quadratic equation and we will try to solve it using the concept of quadratic formula. So the quadratic formula states if you have a quadratic equation ax square plus bx plus c is equal to 0, you will get x is equal to minus b plus minus root over of b square minus 4ac by 2a. Now, if we use this formula to solve this quadratic equation, x will be equal to minus of minus 280 plus minus root over of b square, that's minus 280 square minus 4 times 12 times 1144 divided by 2 times 12. You can use your calculator to find what are the different possible values of x. Using our calculator, we can find the different possible values of x are equal to 18.052 and 5.281. So these are the two values which can either maximize or minimize the value of Vx. Now if you try to plug in 18.052, we can see that the second bracket goes with negative. 26 minus 2 times 18 point something will give you a negative value. Since volume cannot be negative, we can discard this value of x and we will use x is equal to 5.281. So new maximum volume is equal to 44 minus 2 times 5.281 times 26 minus 2 times 5.281 times 5.281. If you calculate this using a calculator, you're going to get 2726.13. So this is the maximum possible volume for the new formula that we got after cutting out a piece of 2 centimeter from all the edges. That's it. That's it for this explanation video. Hope you have liked the explanation. Please feel free to reconnect with IITN Academy for more such interesting explanations. Thank you.